Oh, welcome to the design of structure analysis 1. We are on going to the theory portion of strain energy. Now the topic is strain energy due to impact loading. Load P is dropped through a height h before it commences to load the bar. Let first see the figure 4.3, which show a small bar P is equal to m into g. M is equal to mass, G is equal to gravitational force, and the height is h, and the change in length is delta L. Okay, first A portion, load versus deformation diagram. It seems to be a normal, and the deflection we can measure. Second one is deformation versus resistance diagram, which are linear. Now, work done on the bar is equal to force into deformation. Force is equal to P deformation into original length or height plus change in length or height. That's we know P into H plus delta L. But we can also say that delta into L is equal to strain sigma into L divided by E. Put the value, we can get P in bracket H plus delta into L divided by E bracket over work stored in the bar is equal to 1/2 delta L into R. Strain energy is equal to sigma square upon 2E into V, because sigma square is equal to, sorry, delta L is equal to sigma upon E, LE. Okay. Mm. Now work done is equal to work stored. Equate equation 1 and equation 2. We get P into H plus delta L is equal to sigma square upon 2E into volume. Through the mathematical solution, we can get the result after solving some section of the theory and put some values of sigma, volume, delta L, etc. The final result as an sigma is equal to P by A plus under root of P square upon A square plus 2E PH upon A into L, stress due to impact load. The final equation is stress due to impact load. And we can also say the another equation like P by A in bracket 1 plus under root of 1 plus 2EAH upon P into L. The difference between two equations is that the common things are put out and the rest of the things are in a bracket. Else in another equation, separating all the things. Okay. Now condition for it, if load is applied suddenly, H is equal to 0. Sigma is equal to, put it in the equation, we can get H0. That's why the whole thing is 0. We can only have P plus A under root of P square upon A square. Remove square and C under root. We can get 2P upon A. Okay. Where delta L is very small as compared to H, then work done is equal to P into H. Okay, sigma square, because work done equation we know sigma square into AL upon 2E is equal to work done P into delta L into H, but delta L is negligible. That's why sigma square is equal to 2EPH upon AL. Remove the square, the final equation sigma is equal to under root of 2EPH upon AL. Now impact load factor. The ratio of maximum dynamic deformation delta L to the static deformation delta ST is called the impact factor. The impact factor I is given by I is equal to delta L upon delta ST is equal to 1 plus under root of 1 plus 2H upon delta HT. The impact factor is used to determine the equivalent static load acting on the bar. Impact load is equal to T and static load is equal to W, which is delta L upon delta ST. The ratio P by W is sometimes known as load factor. The static stress due to gradual loading may be multiplied by impact factor to calculate the stress due to impact load. Now, strain energy due to shock load. If U is a unit of energy are transmitted by shock, they will be absorbed by the bar and stored in the bar as a strain energy, provided that the elastic limit is not exceeded. Let us start the solution. Work done on the bar by shock is equal to U. Work stored in the bar is equal to 1 half R into delta L. R is equal to sigma into A. Delta L is equal to sigma L upon E. Put the value and we can get the sigma square AN upon AE. U is equal to sigma square upon 2E into A into L. Now sigma square upon 2 U upon E upon AL. Okay, which is maximum instantaneous stress. Now relation between strain energy due to gradual load and strain energy due to sudden load. Stress due to gradual load. Sigma is equal to P by A. Stress due to sudden load is equal to sigma is equal to 2Pa by 2P upon A. Stress due to impact load is equal to sigma P by A in bracket 1 plus under root of 1 plus 2EAH upon PL. There are the equation we need to idealize and memorize. Stress due to sudden load is twice the stress due to gradual loading. Stress due to impact load is more than twice the stress due to gradual load. Strain energy or gradual load, which is mu U is equal to sigma square upon 2E into V, which is also known as P square upon A square into 2E into V. Now, strain energy due to sudden load equation is equal to mu is equal to sigma square upon 2E into V. Put the values of various character of the equation, we can get 4P square upon A square upon 2E into V. From equation 1 and equation 2, strain energy due to sudden load is equal to 4 times strain energy due to gradual loading. Okay. Now, the next theory is strain energy due to shear load, which can conducted in our next lecture.